In this video, we are going to look at how to solve problems on conservation of energy. So here we have got a 250 kg car which is initially at rest at point A on a roller coaster track. The car carries a 50 kg passenger. So we can see there are 2 kgs, 250 kg car and 50 kg passenger. So the total mass will be 250 plus 50, which is equal to 300 kg. And the initial velocity is 0 because car is initially at rest. Then it says car carries a passenger, 50 kg passenger, and is 20 meter above the ground at point A. So the height is given, the initial height is given to us as 20 meter. The track is friction free and there is no appreciable air resistance. Remember throughout all these types of problems that mechanical energy remains the same at every point, it remains constant. And mechanical energy is equal to gravitational potential energy plus kinetic energy. So it is potential energy plus kinetic energy. In this case, we have gravitational potential energy, so we are going to write GPE plus KE. It's asking us to calculate the total gravitational potential energy relative to the ground of the car and the passenger at point A. So for both car and passenger. So we'll apply the formula for GPE, which is mgHA. Why HA? Because you want to find the gravitational potential energy at point A, so we have to take the height at A. Now we have all the numbers. 300 is the mass, G is constant, which is 9.8, and 20 is the height. So we can multiply it and we can get the answer as 58800, and the unit is joules. Part B, calculate the speed of the car and the passenger at point B. So we want to find the speed at point B. So we'll write conservation of mechanical energy, MEA is equal to MEB. Then we will substitute the formula GPE plus KE at A is equal to GPE plus KE at B. Now at A we know that the car was at rest. So at A the car was at rest. So we can remove KE, that is kinetic energy, which will be 0. So we have GPE equal GPE-B. So now let's just think about point B. Point B, the height is equal to 0. So HB, the height is also equal to 0. So GPEB will also be equal to 0. Now gravitational potential energy at point A we calculated in the first part. We can see that we calculated here. So we can substitute that, which is equal to KEB. Now KE is kinetic energy. The formula for kinetic energy is half mv squared. We can substitute that. Substitute the mass. We want to find the speed of the car. That's what the question is asking. We can use the calculator to solve it, and we get the answer as 19.8 meter per second. Part C, if point C is 5 meter above the ground, find the kinetic energy of the car at C. So now we want to focus on this point C, which is at a distance of 5 meter, or the height is 5 meter from the ground. And we want to find what's the kinetic energy of the car at C. So we'll again apply conservation principle. MEA, mechanical energy at A is equal to mechanical energy at C. Replace it with its formula. Let's get the diagram here and label the height as 5. Now, obviously kinetic energy at A is equal to 0 because we said that at this point the car is at rest. So, and GPEA we calculated in part A, we can substitute that, which is equal to mgHC. So we are substituting GPE with its formula, but we are keeping kinetic energy as it is. The reason is because the question is asking to calculate kinetic energy. So we will keep it as it is. We will not substitute it with its formula. Substituting the numbers, remember that the height at C is 5. So we are substituting the height as 5. Then we can solve it using calculator. We get the value as 44,100 joules.